The UMass Aeronautics placed first in New England during a design, build, and fly event last weekend.
Jack Wood with the 22 News Storm Team is live in studio with how UMass beats schools such as MIT.
Good evening, everyone, and welcome to SocialFlight Live. We have a wonderful show for you this evening. The University of Massachusetts Aeronautics team is here. We're going to learn about the Design, Build, and Fly Challenge and some of the amazing things that these engineering students are learning in competitions like this that will help drive the future of aviation. Before we get started, just a few things. Spring flying is just booming as we approach summer now, and we have tens of thousands of aviation events and destinations in SocialFlight going. Be sure to just check out socialflight.com or the free mobile apps for Apple and Android devices. We have all these destinations, crew cars, $100 hamburgers. We've got our Fly to Win challenge where you can win prizes. We just gave away a Lightspeed Delta Zulu headset. Our winner was Stuart Philpott of Taylorsville, Kentucky. And we've got another Delta Zulu headset from Lightspeed that's going out and going to be won by someone on June 1st. All you need to do is get the free SocialFlight mobile app for Apple and Android devices. Check in at least one airport, even your home airport, and you're entered in to win. Get on our leaderboard. You get extra entries. We're just here to support all of you, and also be sure to check out our FAA Learning Center, which has all these courses you can take for wings credit. You can take maintenance technician credits. If you're an AMP with IA, you can go on and get your certificates for continuing education. It's all there. It's all free. Thanks to everyone on this board right behind me. And I just want to say thank you to all of them, and thank you to all of you for everything you do to support general aviation. Tonight's broadcast is brought to us by Avidyne and the amazing IFD 550, 540, and 440 series of navigators, and the new Avidyne Vantage system that is literally going to revolutionize the panels of Cirrus aircraft. There's some news coming soon from Avidyne. Pay attention, stay tuned. We'll be one of the first to bring it to you. And also, we use a 550 and a 440 in our Bonanza, and you're going to see a lot more videos from that Mustang behind me here, where we are putting in an IFD 550 with a forward-looking camera that's already installed, and there's some cool things coming for that. So much, much more to come. Now to tonight's show. I have been very, very fortunate to get a glimpse inside the world of engineering students as SocialFlight has supported and sponsored the UMass Aeronautics team, where my son Jake, which you may know from many of the YouTube videos, is a student and the team program manager. It really has been a privilege to see this incredible group of young adults literally building this winning program at a school that doesn't even have an aeronautics engineering major. They really built this program from the ground up. We're going to talk about that tonight, along with what it's like to be inside a competition like this. And so I wanted to share this story with all of you, take you behind the scenes, see what it's like to participate in this team effort. And you know, these folks have to be as creative and resourceful as possible to compete internationally with some of the best university programs on the planet. They just returned from the Design, Build, Fly Challenge competition out in Tucson. We're joined tonight by Jake Simon and Nate Ware. They are by no means the entire team, of course, but we couldn't fit everyone on camera, and I understand there's exams going on as we approach the end of the semester as well. So we'll have these guys explain it all to you and what it's like. Please welcome to SocialFlight Live, the UMass Aeronautics team. Hey guys, how are you doing?
Good, good. How are you?
Excellent. Thank you so much for taking time. I know you guys are very, very busy, would be an understatement. You've got exams. You two are getting about to graduate there, but
Mhm.
I'm sure there's a lot going on. Um, I want to start with a little bit first, just to let people get to know both of you a little bit, and now I want to talk about the team and background and what's involved in all this stuff. Hey, Nate, let's start with you. A lot of the folks here are not at all familiar with you. I've obviously spent a bunch of time with you, and I have an enormous amount of respect for you. Tell me a little about your background and your major and where you're going now on graduation.
Absolutely. I'm a senior electrical engineering student, and my role on the UMass Aeronautics team has been the chief engineer for this past year. And yeah, I've really enjoyed going through the engineering process and leading the team through the design and uh, architecture of our plane. And going forward, upon graduation this year, I'm going to be joining STR full time as an employee in Woburn, Massachusetts. I'll be a associate engineer there.
What kind of
Um,
work are you going to be doing there?
I'll be working with software and sensors to combine, yeah, my electrical engineering knowledge with some coding in C++ and some other languages.
Do you know what kind of products or what market that is?
Yeah, so it's a defense-oriented company. They work on contracts for primarily like the Navy and the Air Force.
Very, very cool. And Jake, fill some people in who may not be familiar with you on your background.
So I am a senior mechanical engineering student here. I've been on the team since my freshman year here, so I've learned a ton on the team, and it's been a great way to really start using what I learned in classes and apply them in a hands-on way. It's really kind of accelerated my learning here, and it's very similar to the other students here. Um,
And
so I've interned a few times at Pratt& and Whitney doing repair design, and last summer doing customer technical support. And then this summer, I'll be going back to Pratt& and Whitney and kind of continuing on the customer technical support role, trying to bridge the gap between engineering and the mechanics, where our real background is.
so you're full
So I've been,
time starting at Pratt and Whitney, going to be working on the jet engines we'll fly behind.
that's the goal. Yep.
You'll tell me all dirty little secrets about how maintenance works at the airlines, or at least what you're allowed to.
Yes. At least what I'm allowed to.
Excellent. So fill people in, guys, on what I mean. You think aeronautics team. It's very easy to think like, okay, does that mean you guys are flying GA airplanes, or what is it? So let's get a foundation for what this team actually is about.
Sure. So the team is a engineering design team in the mechanical industrial engineering department, but we take a lot of other engineering students. For example, our chief engineer, Nate, is an electrical engineer. So we have people from computer, electrical, mechanical, civil, industrial, and we're all trying to come together and compete in the AIAA Design, Build, Fly competition. So it's a big international organization, and they compete, or they have this competition where I think 112 this year universities get accepted into the program. And every year there's a new set of rules, a new set of usually 3 flight missions and a ground mission. And then you go from there. They just give you the rules to, how they're going to score it, and then some very basic guidelines with wingspan and what kind of propulsion system usually has to be off the shelf components, electrical propulsion instead of maybe like a nitro powered remote control aircraft. But the goal is to design, build, and fly a remote control aircraft to do a certain set of missions depending on the year, and then go write a design report, prove your analysis, go to competition, which alternates between Wichita, Kansas, and Tucson, Arizona. And then we fly and we compete. So they can probably give you a little bit of insight into this year's competition as well.
Yeah, and I want to make sure everybody understands here to give you guys due credit for having watched this on the outside. you mentioned there was 112 teams accepted. That's the second cut. Like, I need everyone, I want to make sure everybody understands. Teams from around the world apply to become part of the competition, and you only get accepted after you pass the first hurdle of how you do that. So Nate, fill us in on first kind of how the competition works, and then what this year's challenge was.
Yeah, absolutely. So every year in September, the AIAA releases the set of rules for the year. And then from there, you have about a month to produce a proposal for how you're going to approach this year's challenge and the setup of your team and other kind of logistical information about your program. If you are accepted among those 110, 12 odd teams, you then are prompted to begin designing and fabricating your airplane through the design process that you proposed. And you work towards producing a 60-page design report that includes your full analysis and other design decisions. And during that time, you are testing and building and evaluating your aircraft. And then, your score on that design report is a factor in the competition results. So each year, as Jake mentioned, there's a new set of rules. For example, this year's competition involved carrying fuel tanks on the wings of your aircraft. You were limited to a 6-foot wingspan, and you were also required to deploy a miniature glider that weighs less than 1/2 pound during flight and pilot your glider to a landing zone. So these were the challenges that we had to assess and make design decisions on how to build and fly the best aircraft possible.
Yeah, that is. I love the idea that you go through this each year, and you're sitting there at this date waiting for this thing to come out. You have no idea what it is that it's going to entail. Give people an idea here, because you guys now are in the 3rd successful year of this program. So, I mean, basically, you walked in and you turned a program around that didn't even exist and managed to succeed 3 years in a row as the first years. Tell us what those missions were. Do you remember what some of those one? Of course you do. First, second, and then this year, so people can understand how they vary.
Sure. So the team started to kind of get its form right before COVID, and it was just kind of starting, and then COVID happened. Never really competed, and it was just hard to get everyone together. People weren't on campus. Then during my freshman year was the first year back from COVID, and we tried to get a team together. From the people who kind of came from then. By that time, the competition was probably taken place for at least 20 years, I think. So a lot of these teams have, kind of pushed through, all those competition years. And I believe that year, being that it was right out of COVID, was you had to design and fly an aircraft that had to transport vaccine vials. So it had to basically be a UAV that would transport it to a remote location. I believe it had a 20-foot takeoff distance, and then you actually had to land. You would have to shoot out a box of vaccine vials that had accelerometers inside of them, so you knew that you didn't break any vials. And then kind of go up, do another lap, come down, and kind of drop another glider. So that was our first year, and we really we were just starting to get the team together, didn't really compete, and that was my freshman year. And going from that point, we knew that we really needed to change, organizationally, change the people that we had, really bring in some new, talent that was really motivated to learn the competition and teach themselves. Because as you mentioned, UMass doesn't have a dedicated aeronautical engineering major compared to some of these other schools that we're competing against. So that was a big thing of trying to research all these other teams. The year after that was our first year where we really started getting everybody together. I still think we probably only had 16 people on the team. And that year was simulating, I believe, an electronic warfare mission where you had to carry a payload and then it would have an antenna externally mounted on one wingtip. So now you have like asymmetric drag coefficients on different sides of the wing, and you had to design a plane that would be stable in that state. We ended up coming second in New England and I believe 24th internationally. And that just proved we can go to competition. Our plane flew terribly. Every single mission, we basically almost crashed. We were on the verge of stall pretty much every single flight. And somehow we brought the plane home. We basically had one time where it came down and then our pilot, Jimmy, maybe 5 feet above the ground, somehow was able to get enough airspeed to pull it up and keep on flying. So no one was thinking that we were going to be able to make it, including us, but we ended up getting down, and that kind of proved we could go to competition. Then the next year was, okay, let's try to be competitive. Even though we don't have any aeronautical engineering knowledge at all, let's really learn our stuff, let's build a bigger team, and let's just try to tackle it from a mechanical and electrical point of view. And last year we had to make a vehicle that would simulate urban air mobility. So the vehicle had to fold its wingtips, fit into a parking spot, unfold itself, and carry a bunch of payload inside and do a bunch of laps. And that was last year's competition. And
people, right? I remember like you guys loading little wooden people.
Right. So the previous years you were actually building a UAV to do UAV things, and this one was like a subscale kind of simulation of like an urban air mobility situation. And last year we actually came in first in New England, beating MIT, and then came in 24th, I believe, internationally. And we really started to build the team. We got our confidence and started to push forward. And then this past year, the competition was, as Nate described, you had these external payloads with this fully autonomous glider that would deploy, but the whole thing is actually based on the X-1 vehicle in the 50s, where they broke the speed of sound for the first time. They had the B-52 bomber, I believe it was the late 50s, and they kind of mid-flight deployed that orange X-1 vehicle that broke the speed of sound, and they kind of came off of that and said, well, now build a bomber aircraft that holds a fully autonomous glider. That was this year's competition.
That's so cool. Nate, why don't you take us through? I want to share your design report. Obviously, this is a hugely detailed report. We're not going to go through it in general, but I want people to get a sense of what the work is that goes into this, because I find it so wonderful and exciting that all the different types of engineering students on the team get to experience how to go from literally a challenge like any company has when they're creating a product, through figuring out how you're going to solve it, presenting that, and then going into production. And there's some key parts in this document. And the other thing I want to do is, it's real pretty in this document, so we can show them this version before they see the real aircraft that you're going to show. So let me share this. There we go. And guys, take us into this a little bit.
Excellent. Yeah. So starting off here, we kind of have some artwork of our aircraft design, and as you can see, that is our glider deploying from our aircraft. And yeah, so starting there, we'll kind of take a step through the
well, I noticed you've done a couple of things here. Like one is it actually teaches you how to manage a project in this Gantt chart.
Correct. So the very beginning, and this comes kind of expands upon the proposal in the very beginning, where maybe you have 200 to 250 teams that apply, and you're really trying to show them that you have a team together with a plan of how to kind of attack the problem. And this very beginning, you can see that Gantt chart there really explains how we planned out the whole season in design and analysis and fabrication and testing. And then also you can see those little the little black lines going through each row, and that's our progress. So we're tracking our progress versus how we planned it. So it's really teaching us, how to organize and manage a product, like you said.
How does this compare to some of the stuff you guys learn in classes? I mean, you're really learning here, obviously. How do you not just randomly run towards a goal, but how do you actually map it out so you achieve it?
Yeah, so in some of our senior classes, we're tasked with or going through the process for a senior design project where you actually produce some, or you go through the design process for a project. And really what this has taught us is, the process of going through preliminary and secondary design reviews where you're designing to meet deadlines and produce an iteration of your design that others can understand and offer feedback on. So that's given us really good insight into learning how to step through a design in the iterative process where you may come up with a design that needs tweaks and other modifications, but you need to polish it to a point where others can evaluate it and offer insights.
Makes sense, obviously. Well, let's, like I said, we don't want to go too much through, but this actually, I do want people to see the course layout of what's actually happening here. Can you explain this loop?
Yeah, so if you can see, there's a runway down at the bottom, and you take off in either direction, depending on the direction of the wind during your flight. You then circle around and perform a 360-degree turn, and then come back and complete the lap, and that's considered one lap. The course is approximately 1,000 feet in length. The straightaways are around 1,000 feet. So you can imagine that this is probably around a half-mile course. So our plane often flies three or most of the missions involve 3 or more laps. And so you can kind of imagine that our flight distances are somewhere in the range of 1.5 to 3 or 4 miles, or yeah, something around there.
And then expanding upon that, so this is how the competition works in terms of scoring. You have this design report that you're seeing right here, which is really proving our team and proving our design analysis and testing. But then you have this whole flight section of it. So this is the flight course that we're flying, and you get graded on how fast you can fly these laps, how many laps you can fly in a specified amount of time, how much weight you can carry. And then with this glider, it's the weight of the glider. So you get points for having a lighter glider, and then you get points for the glider's accuracy in landing in a bonus box. So basically the goal of the competition was to make a fully autonomous glider that would deploy in flight out of our main plane, and then have to try to land in this bonus box to get these extra points, to help our flight mission score. So there's kind of 2 ways to do that, and we can kind of step our ways through this briefly. But basically, you can have a fully passive glider that is just inherently stable. You drop it right on top of the bonus box, but then you have no control over the wind. You have no control over anything. You could just fly away and never see the glider again. Or you make a fully active glider that has gyros and magnetometer and accelerometer and GPS and things like that, where it can actually navigate towards the center of that bonus box and try to kind of maximize your ability to get those bonus points.
Yeah, and the other thing, obviously, you guys are learning is the trade-offs, because you get points for different things. And I remember you telling me from one of the past competitions how like one team with like wing strength or something like that basically built something that didn't even look like an airplane. It was just built to win this one part of the challenge, because you're like, well, where are the points, right? Tell me a little bit about balancing priorities.
Sure. So if you scroll down, I believe it's page 10. We've clearly looked at this enough. Yeah, so two up, and you'll see this sensitivity study. And this is what we do kind of very much in the beginning of the competition, but we're tweaking it throughout the season, is you have these equations that tell you you fly this many laps and this much weight, and you drop the glider in this position or this close to the landing zone, how many points you get. But if you make a plane that carries a ton of weight, it's going to fly really, really slow. And if you make a plane that goes really, really fast, well, maybe you can't carry as much weight because now you're building a really light, really streamlined plane with not that big of a wing. So you have to balance these things, because if you're average at everything, you're actually not doing that well in competition, because your goal is to be really, really good in a lot of the missions. Sometimes the strategy is get really good in one mission and just try to minimize the losses on the other mission. So it's this whole trade-off of whether you want to be okay at everything or kind of prioritize one without losing the other. And that's what these trade-off studies are doing, is we're trying to kind of mesh some physics and mesh a little bit of just the equations, trying to figure out what's really possible.
Yep. And obviously you look at different kind of ways that you could have built it, things like that, which are good ways that you could have done different, obviously things that we don't want to take people through like the whole thing. But this is really detailed work that you've done to come up to this. Tell me a little bit about that.
Yeah, so that's our one of our analysis that we do in the very, very beginning, which is trying to figure out, after we do our sensitivity study, it's okay, let's try to figure out how to build a wing. And you got to start somewhere. There's a million options that way you can do. So what we did this year is we started by choosing an airfoil. And it's okay, what airfoil is going to best balance the properties that we want? And you can kind of see the table in the bottom of trying to weigh the pros and the cons of different aspects of the wing. And then you can see kind of on top all those different lines. Each line is a different airfoil, and we're trying to figure out its coefficient of lift and coefficient of drag and its efficiency and its stall characteristics. This just as a starting point to then expand upon on wing sizing and geometry and things like that.
Yeah, very cool things, and just really, really detailed work and analysis that you do. And that's that part of it. So then you get to the sort of soda bottles. Tell me a little bit about this.
Yeah, absolutely. So for your fuel tanks, you needed to use a commercially available bottle. So one of the evaluations that we had to do was which bottles are the most aerodynamic, and should they be flying forwards or backwards? And so we ran some simulations on all sorts of brands. We got Dasani, Poland Springs, like Smart Water, the whole shebang. And we ended up settling on Smart Water as one of the most aerodynamic and like volumetric bottles. And then we ended up discovering that it is actually more aerodynamic to fly them backwards with the bottom of the bottle into the airstream. And thanks to some of our simulation guys, we're able to find these, find out these things and really elevate our designs.
I love that. So pilots should be drinking Smart Water from the bottom up. That's the lesson.
Yep, exactly.
If there is a lesson. So there's a lot of stuff here, as you can see, the way that you design things in the fuselage, landing gear, stress studies. You really learn how to do all these things that apply to regular aircraft. And here's your glider. Tell me about the glider.
Yeah, so we ended up pursuing an active navigation system. So we deployed one of our sub teams to work towards a fully autonomous navigation system that features the electronics that Jake was describing, the magnetometers, the accelerometers, and attempts to establish an autonomous control method. And we also, so then that was the kind of electrical side of things. We then decided to pursue a a flying wing type design for the aerodynamic structure, and that allowed us to achieve stable, like maneuverable flight for our glider, so that we could enable that active control.
Very, very cool. And we're going to show people images of that soon as we do that. But again, a lot more detail here to the report, and then you get into how you did systems and things like that. All right, so now we've got a little more graphics for people to see about how this all came together. Can you talk us through this?
Sure. So this is kind of the exciting part, and I actually have some things that I can kind of show as well. So as the team progressed, we're actually able to use better materials with better strength to weight ratios, and really start to pursue advanced ways of building aircraft, very similar to how some new aircraft are made now. So in the very beginning, years ago, 4 or 5 years ago, we were basically making normal balsa wood aircraft, and they're very great. They're light, they're fairly strong, but they're very brittle. So if you ever get in a crash, or you touch it the wrong way, and now you got to go and you got to get your CA glue and fix it up, and you're not getting any strength from that balsa wood. You're really getting the shape of the aircraft, so you have to put structures inside. So the next step of that is, okay, how can we make the structure of the plane, the shape of the plane start to carry load? And that's where we start moving into composite materials, because now you can have the skin of the aircraft hold a lot of the load. You can have the airfoil shape of the tail hold a lot of the load, and now you can make a light aircraft be really, really strong. So one thing that's kind of interesting is we have to build a spar. So everyone knows, these wings have spars, and you got to carry the load from all the G's that you're pulling to try to get the fastest lap. So this is something that we actually have been taking from these winning reports, trying to mesh everything together of what we know and what has worked in the past of how to build these spars. And you can see, so this is a kind of a cutaway of one of our spars. It's a wrap of carbon fiber, and that's what really holds the tension force in the bottom, and it doesn't really do much for compression, but it's really about this kind of bottom surface that you're getting. Then you have a foam core, and that's what's giving you your cross-sectional area, trying to increase the moment of inertia of the beam, and you're trying to decrease your bending in your structure. But then you need to get a little stiffness, because these carbon fiber parts are fairly flexible, and a lot of the other components in the aircraft that are not carbon fiber are not flexing the same amount. So if you're able, even though this is really strong and this is flexing, you may crack another part. So we need to add some rigidity, and you can see there's these really thin wood kind of vertical supports that are meshed in here, and that's what is really stiffening this load. So it's really a full composite material where it's wrapped in carbon fiber, your traditional composite material, but then it has this foam for cross-sectional area, and then you have a little bit of stiffness, and all this together we're able to hold upwards of on a 6-foot wingspan, you can put 50 to 60 pounds just right in the center of your beam, and the whole spar weighs like 0.4, 0.5 pounds. Wow. So it's pretty cool stuff, and it's stuff that you kind of dabble in your classes, but you really get to apply and test it. So it's really fun.
Yeah, and I remember one of the things is also fun watching. I got to see along the way at a couple visits things like you all of a sudden added all this weight. I want to be clear, that's a lot of weight in those fuel tank soda bottles or whatever, water bottles that you had on the side. How much weight did you put on the wings?
Yeah, we were carrying 20 pounds of payload between a 6-foot wingspan this year. And the plane itself was an additional 12 pounds. So we were able to, we had a 32-pound combined strength or wingtip strength tests.
And I remember coming up during some of your development, and I remember seeing you guys first put on, or early on, put on those weights, and then all of a sudden it's like, great, and then the landing gear splayed out.
Oh yeah.
There's a lot to work on.
Yeah, and I actually have one of those here. So we're making everything in-house, but again, we're competing against these teams that have $200,000 budgets, and we're just building our team. So we're thankful for the sponsors that we have and from the support that we get from the school, but we really have to think outside the box to be able to make composite parts like this. So all our composite is
Hold on, you skipped over what your budget is, because your budget from like the first year to this year, you're still in single-digit thousands.
Yes, we are. Yep. So everything is on a budget, and to the extent as how do you make composite parts? Well, you usually need a vacuum to kind of take out all that epoxy instead of just having a layer of epoxy on top, and also hold some pretty complex geometries in place. You need a vacuum. But vacuums are very expensive. Vacuum bags are very expensive. All our carbon fiber is expired carbon fiber from all these companies that are about to put it in the dumpster, and then our teammates who are interns there just put in their car instead. And so, for example, we made our fuselage. We made a 3D printed mold. We took Teflon tape and we taped the whole inside of the mold, and then we put our carbon fiber in. We put the epoxy in, and then we took a used trash bag, and we took the trash bag and we wrapped it around, and you turn the pump on, but of course the trash bag rips, and then you duct tape over that, and you try to get the best vacuum that you can. So, our carbon fiber parts, if you were to buy them, are, I don't know, $10,000-$15,000 worth of carbon fiber, and we probably spent $200.
Well, I want to make sure I put a shout out to anyone. We've got a bunch of people watching. Some of those people either work at companies or have other ways to help and support. And I do want people to understand you're competing internationally against, as you mentioned, teams from around the world that may have a budget up to $200,000. And your budget is like $2,000 to $4,000. And so seriously, this isn't meant to be like a play for money to everyone, but if someone knows of like vacuum pumps from someone having gone and built a composite aircraft, or someone built a long EZ one day, many years ago, or something like that. There are programs like this, the UMass Aeronautics program, that would love your equipment to help them not use trash bags and other things in duct tape to try to do it. So anybody, if you can help, we will certainly send you to UMass Aeronautics website to get in touch with teams for the next year, and anything you have can often help these guys. But you really have had quite a great degree of success using whatever you could scrap together. So again, take us through some more here. I brought up another drawing here. It shows your motor and you tell me what it shows.
Yeah, absolutely. So as you can see, we've got our propulsion system, which is all electric. We use lithium batteries to power our electric motors. And kind of a little statistic about our motor this year, it actually had power similar to that of a 30cc gas motor. That was kind of one of the comparisons that the vendor has highlighted. And that is actually what gives us those 30 pounds of thrust to give us that 1-to-1 ratio during flight, so that we have the control that we need. And we've got a little bit more in-depth drawings for some of our payloads. As you can see, there's a lot of CAD work that goes into the design of our aircraft. So each of these components is getting hours and hours, sleepless nights of CAD time, and it really pays off. It allows us to have some of the most technically advanced mechanisms. For example, our payload mechanisms featured a pylon design that was fully machined and designed by one of our members, and they were one of the fastest mechanisms at competition. So it really kind of goes to show what you can do with tools like CAD and just some hard work, some really driven efforts to really achieve success in against some of these high performing teams.
And one thing that I'm going to add is these release mechanisms that you see, like that little pylon on the middle left. and then also what holds the X-1 vehicle. So the ground mission this year was you have to load everything in your aircraft as fast as possible. And, you have to set a really high standard because all the other teams are trying to win that same mission. So this is probably iteration number 60 at least, which is crazy. And everyone probably hated Nate and I because we were like, no, it has to be faster. It has to be faster. And, we ended up coming out with the whole plane can basically be assembled in 6.9 seconds. After almost 60 iterations, we're going to probably just put it all in a big bucket of epoxy and throw it in the river. But because we're so done with all the iterations, but it's really fun, and it's all about thinking outside the box. And a lot of these parts were made by freshmen and sophomores.
Yeah, that's absolutely awesome. And again, a lot more detail in this report. You guys did a great job with this. I do want to show some of the photos. Let's see the airplane. Let's see more. So let me change over from this to let's start with one of the basics, which is this is the whole team, right? It's a great group of people. I want to make sure. Obviously, we have only you two with us tonight, but this isn't possible without this amazing group of young adults.
Totally. So we actually have 36 people on the team, and only 7 are graduating. So we have 29 people that are going to stay with the team and continue building it once we go. And so that we're really, really proud of. And then all these students are anywhere from first year in college, all the way to seniors in college getting ready to graduate. And we really try to distribute the workload, and as freshmen really try to have them own projects, and that's the only way to learn. You can take a SolidWorks class or a CAD class online, but it's only going to take 60 iterations to really understand it. So yeah, that's really great. And then also all these people on the team, they want to pursue something with aviation or aeronautical engineering to some capacity. They came to UMass to get a really strong background in electrical or mechanical, but it's teams like this that lets you kind of get into those industries. And we actually have a lot of people on the team. I think even this semester we have 2 or 3 people on the team that passed their written for their private. One person that I believe just soloed. I think we have 3 or 4 people that already have their pilot's license. We have a chief, what is it? Crew chief for the F-15s. So, we have a lot of people from a bunch of different backgrounds that want to get into aviation, and, this is their way to do it. So, it's really fun to get everyone, who's
That's wonderful. And one last thing before we get into showing some of the photos of the airplane, and that is another thing I was really impressed with all of you on is, again, you went from not flying not ever in the history of the school being able to fly in competition within 3 years, all the way to the point that this year you really focused on having a succession plan and organization for the team, so that when this sort of pioneering group graduated through, there's a formula for everyone to follow, so you keep improving. Tell me a little bit about that focus that you had this year.
Yeah, absolutely. So we were kind of working directly with some of the future prospects for leadership positions to kind of hand down this tribal knowledge that we've acquired. And I use that term a lot. I'm sure it's pretty common in industry, but there really is like an understanding of the design process that is really unique to this team. And so getting really close to our younger classes of students and trying to pass down as much of that knowledge has been, one of our main focuses. In terms of some of the efforts like the aerodynamics, the aerodynamics calculations that get done, Jake has developed a framework for going through that process. Where do you start? What do you prioritize? And similar processes for each of our divisions, including our propulsion and mechanical and payload systems. So we're really aiming to pass down this knowledge and keep up this standard of excellence that we've established.
That's great. And it even includes kind of organizationally, like what is the organization? Tell me about that.
Sure. So what it is right now is constantly evolving, and we're actually going through that process right now, is really trying to push the people who are going to take over the team next year to not feel like they have to keep the same exact framework and mesh it in a way that they can take the learnings of this year, figure out what are just places that we need more focus, or maybe a little bit of less focus, and kind of shift the organizational structure slightly. But basically, in general, we act as two captains, so Nate and I, where we have a program manager for one of the captains, and kind of deals with a lot of the administrative stuff, but really about making sure that knowledge gets passed down, and we have a plan for the whole season, and things like that, where Nate's the chief engineer who's really looking at our design process, and the deadlines for when we have to meet certain goals, not exactly the goals set by the competition, but goals for us so we can iterate quickly. And then we have a bunch of divisions, kind of under the captains, where we have an aerodynamics division that has the lead, and each one of these divisions has their own lead with someone who's been on the team for at least a year or two. So we have aerodynamics, we have electrical systems, we have airframe structures, mechanical systems. This year we actually had to make a whole new division just for this fully autonomous glider. So with all these divisions, you're able to kind of try to distribute the massive amounts of workload of trying to design something that hasn't existed before, that all the other teams are also trying to do the same thing. So.
Excellent. All right, well, let's tell the story of this year then, because that was a lot of fun to watch from the outside here. I'm not gonna lie, I was kind of jealous of not being there and going and doing some of this. It sounds like it's exhausting, but a ton of fun. So this is the team that went out. Tell us about this. Tell us about the plane.
Okay, I got it. So we were, fortunate enough to be able to take 13 people to competition this year. We got a little bit of support from the college to help make this happen, primarily so we can continue to pass down the knowledge, because we talked about this tribal knowledge. A lot of it comes from just being at competition, knowing how, how to deal with the other teams, how to deal with competition, going into technical inspection, things like that. So you can see our plane in the middle. These are the kind of 13 individuals that we were able to bring to competition. It takes place in Tucson, Arizona. So just to the west of the national park that's just hugging Tucson. They put us right in the middle of the desert where we can't, we're a runaway plane, can't hit anybody. And there's a lot of runaway planes, and ours included, which we'll talk about soon. But yeah, so this is again our plane. One thing that we learned from 2 years ago in Arizona is that it's actually a lot hotter in Arizona than in the Northeast. Who knew? So you can design something great in the Northeast, and then you forget that it's actually way hotter, and everything changes, and 3D
everything melts.
Start to melt. Same thing happens with composite parts. They start to deteriorate, and that's why long easies and everything's made, painted white, and a lot of planes are painted white. So we had to do the same. Still had issues, but you try to mitigate as much as you can.
So this is the aircraft, and those weights on those pylons. So talk a little bit about that and how they attach and things like that, because I want people to understand those are filled with what? Wet sand. Those, when I held one of those, they are really heavy.
Yeah, so this year we decided to pursue as heavy of a payload as possible. And so in order to get the maximum weight with the minimum volume for those payloads, we used a steel shot sand and filled the bottles with 10 pounds of the steel shot. And then they're mounted with aluminum machined mechanisms that, as Jake was mentioning, took 60 iterations. but were able to be designed to bear that load in 3 or 4 Gs that the plane experiences during flights. So yeah, when we're picking them up, it's pretty heavy. And like,
You design and you're like, okay, this plane's going to be able to hold only 30 pounds. Like, it's going to be fine. And then you pick them up and you're like, oh God, this is way more weight than what we thought.
I don't even know if like I can hold these up,
Yes.
much less something in midair. So that's always one of the things that, turns out to be more significant than, you could have planned for. But yeah, we were able to bear that weight and yeah, built a successful design this year. It performed well during our test flights and gave us the confidence to go and aim high at competition. So this was us here at the competition, assembling the plane on the runway, getting ready for one of our flights. As you can see, we've got an umbrella trying to shield some of that heat off of the plane to keep it cool.
Another learning from 2 years ago.
We noticed a lot of the higher performing teams doing this with their carbon fiber fuselages and other components. And yeah, we decided to implement it. It paid off.
Yeah, and that's our team carrying our plane to the ground mission. So again, the ground mission's how fast you can assemble all the payload onto your plane. So we built the stand to elevate the plane a little bit, make it level, and then also kind of secure it down with safety wire. Make it so you can, our payload loader can go as fast and as hard as he wants, and the plane doesn't budge. So that's us all kind of walking over to ground mission.
All right. So tell me what happened. Let's tell everybody how each of the flights went and be honest. Let's go.
Absolutely. So we got off to a great start. On our first day, we passed tech inspection on our first try with minimal hiccups. We were the fastest team through tech inspection because we had all our ducks in a row and our plane was ready for flight. On the second day, we successfully flew our first mission in the morning that day, and that was a really big boost. We were off to the races, off to a really good start. And then Jake, do you want to?
Sure. So then we did ground mission. So ground mission is often a competition, just something that you can kind of drop in and do whenever you have time. So we went into ground mission, I think we got the second fastest ground mission at that time, knowing that we could have a second shot at ground mission and really fine tune our skills there with the pressure and the heat and everything. And I believe we got probably like 13 seconds, I think, was our current time the first day.
Explain to people what are you doing in those 13 seconds? This is your ground mission.
So they start the timer. You put these kind of pylons on that hold the fuel tanks. You put those in, and then the timer stops. And you also have to take all the hatches that cover all the holes on in that time. Then when the timer starts again, you get to put the glider in, and you put those bottles onto those pylons. And then the timer stops there. So that's the ground mission. Some teams, maybe take a minute or 2 minutes to put it on because you got to screw things in. Some teams were 30 to 40 seconds. Our first one's at 13 seconds. Then we went back and all night we were, based on what we saw from other teams, what we thought we can improve, we cut our time from 13 seconds to 6.9 seconds. And the winner had 8.8 seconds. So, we were totally confident. We were going to, go to competition, sweep everyone out of the water. And, we're mechanical engineering based team. This is where we can excel. And then the next day we got to competition. We were ready. 6.9 seconds again. We're doing great. We go and, we saved that iteration with only one try left to go. So, as things happen, you go up to put the pylon on and then it slips and, you got to pick it up and put it in. So we ended up having, I think, we got 11 seconds. That gave us a third fastest ground mission time. but it's like the knowing that you could have had the fastest, and you had the fastest, but the score sheet doesn't say so. And then we had mission 2.
And that's where things started to unravel. So we went up to we approached the flight line to attempt mission 2. And part of the beginning stage of the mission is to assemble your aircraft and install those payloads and your glider as well. And unfortunately, during the assembly of the plane, I was the assembler, and I left the glider underneath one of the wings out of my sight and forgot to install it during the setup stages of the mission. And unfortunately, due to the very strict nature of the competition, they don't allow any mistakes. And so that kind of goes to show the level of like competition that you're facing. And unfortunately, we had to scratch that mission.
And this taught us about checklists. We have a lot of pilots on the team. No one likes checklists, apparently. And I guess we didn't have one for that specific staging mission. So.
Checklists, everybody. For everybody watching, checklists. There's more to it than just using it for regular pilotage.
Yeah, definitely.
Unfortunately, yes. And so we scrapped that mission and waited through the flight order again to get another chance at the flight line. At our second attempt of mission 2, we completed the assembly and initial stage of the mission. And then during flight, our pilot was adjusting to some wind conditions and adjusting the throws of his control surfaces, and unfortunately hit the glider release switch prematurely. And due to the inappropriate timing, that also disqualified us from the completion of that mission. So we unfortunately had to scrap again and get back in the flight order to try and attempt mission 2 for a third time.
That also taught us that we need industrial engineers who take human factors classes to say, don't put 2 important buttons that do completely different things right next to each other that look exactly the same. It's almost like the Bonanza, 35 that had the piano keys, and you put like the gear right next to the flaps, right next to the light switch. They all look the same issue.
And so on our third attempt of mission 2, we were unfortunately facing some 30-mile-an-hour gusts, but we completed the assembly, launched the aircraft, and flew our 3 complete laps in crazy wind conditions. Our pilot is
like 35-mile-an-hour winds, something that we wouldn't even fly with in a normal aircraft, but we were making it through.
Jimmy got our plane down, landed it with payload, and we were able to achieve a successful score on mission 2, which was a massive relief. And that kind of secured our place in the rankings as well.
Excellent.
And then we had mission 3, which same thing, no checklist, battery issues led to plane unfortunately going down prematurely. So basically, we had a great design report, best design report we've ever had this, in the last 3 years. We came in 25th out of 110 teams, in the design report.
Well, even with all this, right? So even with these challenges, you guys managed to come in 26 out of 112 after all that, first in New England, beating some very prestigious schools. And so my hat's off to you. I think everyone who's watching tonight would certainly agree that you put the work in, and that is why you came out with the ranking that you did. And mistakes happen, and it's in a different way. Like, you guys, the team will know for next year
Definitely
how to be a little bit better about checklists, about some other things. So it's not the very little last part of execution when it's really a year's worth of work, or the academic year's worth of work that got you there. I consider you guys an amazing success. I really do.
Thank you. And I think we're both really happy with the state of the team. We built one of the best planes there. We had a great, design framework behind it, ton of analysis. We really had a great plane. You can even see it, hanging right above us with the glider and the plane.
That's so cool. It's like being in the little mini Smithsonian there.
Yeah, that's what we're trying to do. And, we made some mistakes, human errors that, we know going next year, with the implementation of checklists, really detailed, thought out checklists, and, some good human factors engineers on our side. We all think, and we know that it's possible to, place in the top 3 compared to, some of these teams that, have been competing for over 20 years and have, really kind of deep aeronautical engineering knowledge. So
it's impressive, and I mean that's why I wanted to share your story with everybody tonight and give people a peek inside the university, especially one that's sort of working so hard to make your mark and do what you've accomplished. I've seen it. The fact that you struggle so hard with holding a pancake breakfast so that you can get a couple more people to be able to fly out there, that you're using whatever you can find in trash cans sometimes to build, that your budget is so low that you're struggling for $3,000-4,000 for a total budget sometimes. Again, competing against teams with $200,000 budgets and programs that have been going forever, and you've really done some amazing things. And so tell everybody actually, how do people find your website to get out there? Because I can tell you that I've been getting messages throughout the show. There are people who want to know more, that want to help in the future, and in addition to that, even that might be making you some offers for some swag, like the shirts that you guys have. Maybe they'll make I know you don't have any formal program for this at all, but maybe if there's someone who tries to help out your program a bit, we can find a shirt for them or something.
Sure. So on the UMass website, you can just type in UMass Aeronautics. It'll come right up. You go to the UMass website and you're going to see the design teams right there. We can also figure out a way to get a specific link there as well. And then also, I know there's a lot of pilots on May 10th. So the Saturday, the day before Mother's Day, we're doing another pancake breakfast at the Northampton Airport, 7B2. Yep, so that's the website, and we're going to be posting the pancake breakfast there as well. It's going on SocialFlight tonight, so you'll be able to see it there, and then we're sending out a mass email to all the EAA chapters as well to try to get as much support. But we're going to have our whole team there. We're cooking a bunch of pancakes and eggs. I think we served at least 150 people at our last pancake breakfast. It's super fun. We try to get live music there. And we'll be making however many pancakes and eggs are required, to bring everybody together. So you're more than welcome to
Northampton Airport, 7B2. Is that correct?
Yes. Yep. Northampton Airport, Western Mass.
Is 7 Bravo 2 for that?
7 Bravo 2. Yep. And that's on May 10th in the morning from 9 to 1. You'll see it on SocialFlight tonight, and you can get all the info about it.
Excellent. Well, guys, thank you so much for coming on tonight. It's bittersweet to see both of you graduating. I'm thrilled that you're going off into the world and going to be doing some really, really great things at those companies and helping to support aviation and all the other pursuits that you're going to be doing. It's really going to be wonderful for all of us, and I'm also grateful for everybody else in the team. But how do you feel? You a little? How does it feel leaving? Are you going to be looking to come back in and see how the next team is doing?
It's a little bittersweet.
Definitely melancholy, but we've already been talking about planning to stay in close contact with the team and help in any way that we can them through the design process. We're both really passionate about this team, and it's been a huge contribution to our college experience. So we want to try and help it be the same way for future students.
Definitely.
Excellent. All right, everybody. You guys have a wonderful, wonderful night.
Thanks, you too.
Thank
Thanks
you.
for having us.
Take care. And thanks to everybody else and all of you for everything you do to support General Aviation. We stay to the end. We're going to show that video one more time for UMass. Before we go, we'll be back next week. That's April 29th, 8 p.m. Eastern Time, with former commanding officer of Top Gun, Kevin McLaughlin. You definitely want to see this gentleman. He is something. And we're going to learn the inside scoop from Top Gun. And then we are going to be off the following week. It's the 120th anniversary of Continental Aerospace Technologies, Continental Engines, and we're going to be down there. You'll get some content from us as we go down there. And then we're back here on May 13th, but the other show, Cockpit to Cal, with myself and Brian Schiff. We're going to talk about spring cleaning, polishing, all sorts of tips from both the maintenance perspective and the flight instructor perspective about how to polish both your aircraft and your skills to get it ready for the summer season. And so with that, I wish you all blue skies, and I'm going to leave you with the promotional video for the University of Massachusetts Aeronautics team. Thank you all for joining us this evening, and I wish you all blue skies.
The UMass Aeronautics placed first in New England during a design, build, and fly event last weekend.
Jack Wood with the 22 News Storm Team is live in studio with how UMass beats schools such as MIT.